Assalamualaikum and a very good day to everyone. My name is Khairino Azizi bin Shafiruddin, and today our group would like to present about the decrease and conquer algorithm. Our group picked insertion sort in the decrease and conquer algorithm. What is insertion sort? The insertion sort is a decrease and conquer algorithm. In decrease and conquer algorithm, there are three types of decrease and conquer, which is decrease by constant, usually by 1, decrease by a constant factor, usually by half, and variable size decrease. The insertion sort fall under decrease by constant factor. What is the difference between the type? The difference being is how they compute its n to the power of x. For example, we have decrease by 1 and decrease by constant factor. For decrease by 1, it is t n equal to t n minus 1 plus 1 equal to n minus 1. For the decrease by constant factor, it is Tn equal to Tn over A plus A minus 1 equal to A minus 1 log An bigger than log 2n for A bigger than 2. The real life example is, supposedly you are playing a game of card. You are given an amount of card from the giver. The card is sorted at first. You can sort it in decreasing order. We will explain on how it works later.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Aizad, firstly from PITS. My matric number is B0319101118. So today I will explain to you about insertion sort algorithm with picture diagram. So on the screen we can see there are several numbers in an array. So they are in unsorted. So we need to sort it in ascending order. So from the smallest to the biggest. So first of all, we need to know how to work with this algorithm. So firstly, we must know we must work from the left to the right. So we need to from the left item to the right item. And then second, examine each item and compare it to items on its left. And lastly, insert the item in the correct position in array. So let's start. Okay, first of all, we need start to with number 2. So on the left of number 2, there is nothing, no items. So number 2 is in the correct position, so nothing will be happen. Okay, we move to the next item, number 8. Okay, number 8, when we compare to the left of it, number 8 is bigger than number 2, so number 8 is in the correct position for now. And then we move to the next item, number 5. So when we compare to the left, number 8 is bigger than number 5, so we need to swap number 5 with number 8. And then now we have sorted 3 elements. And then we move to the next element, to the next item, which is number 3. So when we compare to the left of number 3, so number 8 and 5 is bigger than number 3, and number 2 is smaller than number 3. So we move one by one until the number 3 is in the correct position. We will be swapping with number 8 and the number 5. So you can see there are 4 elements in sorted array. So we move to the next item, which is number 9. Number 9, where we compare to the left of it, so there is no change happen because it is the biggest among the number. So 9 is in the correct position. And now we move to the last number, the last item, which is number 4. So when we compare to the left of number 4, number 5, 8, and 9 is bigger than number 4. And number 2 and number 2 and number 3 is smaller than number 4. So it will move in the between of number 3 and number 5. So, number 4, we will be swept one by one until the number 4 in its correct position. So, the number are sorted in the correct order, in ascending order, from the smallest to the biggest. So, as we know, as we can see, insertion sort algorithm is a straightforward algorithm. So, there is no much operation involved. So, I think that's all from me. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.
Hello and Assalamualaikum, my name is Ahmad Firdaus and right now I will explain how to implement the insertion sort. Right now I already declare an array with the size of 9 and I have over here the insertion sort function that accept the array value and the size of the array, but I still don't have the insertion sort function. So I will implement it and explain how it's work in this video. Okay, first let's create the definition of the function first. Insertion sort is a sort where we compare the index with the left side of the index before it, and the index before it is bigger than the index right now, then two of them will be swapped. And this process will continue until the index before it is less than the index right now, or the index is equal to the 0, where there is nothing to compare with. So to implement it, firstly we need to make a for loop that start at index 1. This for loop is to check each of the element for the process. First, we need to assign the element we are right now to a value. Then, we need to assign the current index number to a variable. So this is the while loop to check the element before it. And the condition for this while loop is while j is bigger than 0 and array at j minus 1 is bigger than value. So when two of these conditions is true, then array at index j minus 1 will be assigned to the array at index j. Then we decrement j by 1 to go to the next left index. After this while loop end, we need to assign this value to the last j index where the while loop stop. So that's all my explanation how to implement insertion sort, and thank you.
For the complexity of insertion sort, the worst case time complexity is O(n) square, the average case time complexity is O(n) square, and the best case time complexity is O(n). The best case time complexity occurs when the card is already, or the array is already almost sorted, and then the space complexity is O(1). The insertion sort take maximum time to sort if elements are sorted in reverse order, and it take minimum time order of n when elements are already sorted. Use insertion sort for array that has less than 20 elements for max efficiency. It can also be used for an almost sorted big array. That's all from me.
Assalamualaikum warahmatullahi wabarakatuh, and good day to everyone. My name is Muhammad Shauki bin Abdul Latif, and my metric number is B0319109393. And today I want to present the assignment 3, decrease and conquer algorithm. In our group discussion, we have select the insertion sort algorithm as the algorithm that we want to present. In my part, we have discussed to suggest another algorithm that is better than algorithm that we have choose, which is the algorithm is breadth-first algorithm. What is a breadth-first search algorithm? Breadth-first search is an algorithm for traversing or searching tree or graph data structures. It starts at the tree roots or some arbitrary node of a graph, sometimes prefer a search key, and explore all the neighbor nodes at the present depth prior to moving on to the nodes at the next depth level. Why we have choose breadth-first search algorithm? Because there are a few advantages of the algorithm. The first one, in unweighted graph, it can be used to construct a shortest path from U to V. The second one, even give you the shortest distance from one vertex U to all other vertices in the graph. For each vertex, just remember the edge that was used to discover it. In this procedure, at any way, it will find the goal. It does not follow a single unfruitful path for a long time. It finds the minimum solution in case of multiple paths. The net advantage is while the process, it will never get trampled exploring the useless path forever, and when there is a solution, it will definitely find it out. And the last of the advantage is if there is more than one solution, it will find the minimum one that requires less number of the steps. That's all from us, and thank you.